Now, you will notice B to F. B to F, right there, yes, in red? How long is that? 3. Excellent. A to F, right there in red. How long is that? 4. Everybody agree? Easy peasy lemon squeezy, yeah? Okay, so it says that we want to compare the ratios, right? So if I'm going to do a ratio of BF to AF, what number will go first for BF? 3 or 4? 3, because that's how we have written the ratio, yes? So we would write A 3 to 4. Agreed? Right? We all know how to write a ratio, yes? Now, there's other ways to write a ratio. How else do we write ratios? For example, if I gave you a test, on the top, there's going to be some numbers. Are those numbers a ratio? Yes, because they are comparing the amount of marks you got compared to the amount of marks available to you, yes? And do I write the ratio that way? How do I write the ratio? 3 over 4. So if that is a ratio, 7 out of 12, 8 out of 9, then does that not mean every fraction is a ratio? Yes, of course it does. 3 over 4, because that is 3 possible parts out of 4. Everybody cool? Easy peasy. Now, what can we do with every single fraction that all of you want to do with it because fractions scare you? What do you turn every fraction into if you possibly can? A decimal. How? 3 divided by 4, right? And we would get 0.75. Now, you're all intelligent young people. Are all those 3 the same things? So could I write an equal sign between them all? Is this also not 75 out of 100? Everybody still good? Is it not also 18 out of 24? And so on and so on and so on. Yes, there are an infinite amount of ways we could write this ratio. Yes? All right. Now, being the intelligent young people that you are, and it is going to be visible on the actual board, I'm going to come up to here right now, and I'm going to write what is CG to AG. What's CG? 9. What's AG?
14. Or 12.
12. Okay, so that would be 9 to 12. Knowing what you know, what is it also?
3 to 4.
9 over 12, which is also 3 over 4, which is also 0.75. Everybody cool? Okay, what's DH? You can't quite see H over here. What's D to H?
15.
D to H is 15, and A to H?
20.
20. Knowing what you know. 15 to 20, which is 15 over 20, which is 3/4, which is 0.75. Everybody cool? All right, now, how many triangles are drawn on the screen? 3. There's the red one, the blue one, and the green one, yeah? Plus the giant one. It's not one of those brain teaser questions where you say 3, oh, but what about the big one, right? It's not that. Okay? There's 3 triangles on the screen, right? Red, green, and blue. Yeah? It's hard to see because we're not on the screen, but we're cool, yes? What is the same in all 3 triangles? Addison.
They're all going up by 3 over 4.
Okay, they're all going the same ratio of, what do we call that?
3 over 4.
No, what do we call this ratio in graphing? We have done a whole unit on it. The rate of change is the same, yes? Slope is the same, yes? What makes the slope? An angle. Which angle makes the slope here? Angle. Which angle makes the slope here? Just A. Big A, right? Because the angles are labeled by the letter, yeah? This angle is in all three triangles, isn't it? Mm-hmm. Did the value of this angle change? Did it spread out any more when I got bigger? Will it ever change? If I take this black line here and I draw it forever up there, say I draw it 100,000 kilometers. Let's change it. 300,000 kilometers. Halfway to the moon, past the moon. What will this line be? I lied. I screwed you up. If I draw this line, 300,000 kilometers straight up to the moon, what will this line be? 4. This line is 300,000, so what will this one be? 400,000. What if this line was 15,000? What would this be? 20,000. Everybody cool? What if this line was 150? 200. What hasn't changed at all? That angle. Is everybody with me? Okay. Now, let me ask you this. What if I put dot, what's my letters here? Dot I right there. Would this triangle, that was a bad drawing, would this triangle have a 3/4?
No.
Why not? Because it's a different angle. I'm going all the way up to here now, yes? Now, what if I put, what if I went out and I went up, oh crap, and I put a dot right there? Would that triangle have 3/4? No. Would it have this by this? Yes, it would. Why? Because the angle didn't change. Just the lengths of the side changed. Is everybody cool? Okay. So now, we can go back to here. And we can talk about... We've already written all this down, yeah? Right? What was it? 9 to 12 and 15 to 20, yeah? So what happened? What happened? No matter what, as long as the angle didn't change, if I compare the vertical one and the horizontal one, what happens? It'll be the same ratio regardless of length. Everybody understand? So, when I compared the lengths of the... Are those the legs or the hypotenuse? Are these two things we compared the legs or the hypotenuse? They're the legs, right? When I compared the lengths of the legs, I know it just went blue. I'm on it. The ratio always stayed the same if the angle didn't change. Everybody with me? So look up. You see that triangle up there? Right? It's a triangle, but just had that end cut off, right? Everybody with me? Okay. When they were building this school, did they build this school somewhere? Take it apart? and bring it back here? That's how they build houses and schools and buildings? How do they build houses, schools, and buildings? Blueprints, right? Are blueprints that big? Hell of a big printer to print a blueprint big as this room, yes? Blueprints are small, yeah? Why is it that a blueprint or a plan allows us to build this? Addison.
They're to scale.
They're to scale.
The ratios are proper.
The ratios are always the same. On the original blueprint, the angle of that triangle was the same, even though it was this big. That's why trig works. Everybody cool? All right, now, this comparison is called the tangent ratio. All right? And it holds true for all right angle triangles. Everybody good? So the tangent ratio specifically compares the legs only. Then in nice big letters, no hypotenuse. Or, of course, hippopotamus. Everybody good? All right. Now, you know how all year I've been saying, don't reach for your calculator for stuff you can do in your head, right? This unit, every single question you need your calculator. Every single one. So everybody get out the calculator, please. If you do not have your calculator, get out your phone because it's better than nothing. Get out something that will do calculating. If you don't have something, is there anybody here that has nothing that will calculate right now? Good catch. All right. Now listen. This is a giant pain in my butt, so please work with me. All of you right now see a gray screen on your calculator, yes? All right. Now listen to me and listen to me closely. Look on your calculator. Find the button that has TAN on it. Does everybody see that button? All right. Press that button and nothing else. If your calculator wrote the word tan on the screen, just sit quietly and do nothing. If your calculator didn't write tan on the screen, put your hand up right now. Okay. If your calculator does not write the word tan on the screen, you must do all calculations in this unit backwards from the way they are written. Okay, I'm going to show you right now. I'm just giving you fair warning. Everybody good? All right, now we've got to do another calculator experiment. Slide back over here. If your calculator writes the word, you are going to push the button, tan. Then your calculator probably shows a bracket, but if it doesn't, it's no big deal. Then you are going to push 35. And then even though you don't have to, you are going to close your bracket and push equals. Do not say the number you get out loud. Just do this. Everybody good? Now, as I was saying to the other people whose calculators do not write the word tan, you do it backwards. You push 35, no brackets, then the tan button, no equal sign, and you will get a number. Is everybody cool? Now, listen to me carefully. If your calculator says, after you have done tan, if your calculator now says .700 blah. Do nothing. Just wait. Is there anybody whose calculator does not say .700 blah? Your calculator does not show that. When you push tan 35, close brackets, equals. Okay, so tan 35 equals, what does your calculator show? Excellent. Now, you, Hannah, look on your calculator screen again and see if it shows a little d or DEG. If it doesn't show that, does it show R and RAD? Or does it show G and GRAD? It says GRAD. You need to look for a button with DRG on it and push it until it says D or DEG. Now do tan 35. Excellent. So everybody listen. Your calculator must show the letter D or the word, well, the three letters DEG to do all the trig in this unit. If it doesn't show that, you need to make it show that by pushing that DRG button or coming to see me. Is everybody clear? Excellent. Now that you have done that, 0.700. Now do it for 15 and tell me what you get. Punch it in the way you need to for your calculator and somebody offer me an answer. I know it's just gone blue. Just continue to work. 0.267. And 45? One. Now let's stop for a moment and discuss this. A 35-degree angle would go from here up. Yes? Everyone agrees? Okay. This is our 90, right? Now, what is this as a fraction? It should not take this long for grade 10s to tell me what 0.700 is as a fraction. 7/10. Excellent. Now, where would that 7 go on this triangle? Would it be the vertical leg or the horizontal leg? Vertical leg would be 7, so what would this be? 10. Or 700 over 1,000. Or 700,000 over 7 million. Over 1 million. Right? Okay. What would this triangle look like? Well, 15 is a way smaller angle, yes? What would this be as a fraction? No, I wouldn't do that. I have 3 decimals here. That is 267 thousandths, right? Where does the 267 go? The vertical. Where does the 1,000 go? On the horizontal, right? Now, neither of them is 0.75, yes? So are either of these triangles the triangle we were working with earlier? No. So can angle A, right there, be 35? No. Would it be close to 35? Why? This is 7, and the angle we were working with was 7.5. So the angle we were working with must be close to 35. Everybody cool? All right. Now, this one's a wee bit tricky. If that's 45 and this is 90, what does this have to be? 45, because triangles have to add up to 180, don't they? If this is 45 and this is 45, doesn't that mean these two sides are the same? Okay, so if this side was 300, what would this side be? 300. And what's 300 divided by 300? 1. Everybody cool? That's why a 45 has a tangent of 1. Is everybody good? So we can all use our calculator to get the decimal. Once we have the decimal, if we wanted to, we could get the fraction and then build the triangle. Is everybody cool? Now, is this triangle exactly right? Is it exactly 7 over 10? No, because of course that gave us 7002983, right? It went on forever. Yeah? But is it close enough? Is everybody cool? All right. So when we have an angle, our calculator will tell us how long the sides are. Everybody agree? Okay. What's different in number 2? I have a decimal here, right? What is that decimal really? What is that decimal really? It's really 75 over 100, yes? Or 3/4, yes? Which means the triangle would look like this, 3/4. And there's my angle A, right? This is the triangle we were working with at the top, right? But we don't know the value of A. Our calculator does. Remember, you have two options here. You either punch in what you see or the reverse of what you see. So if you are one of the people that your calculator puts the word tan on there, look for your button that says second or shift. And then push tan. And your calculator will write tan minus 1. Everybody sees and does that, yes? So all of you forward calculator people, you are going to push tan, shift, tan, 0.75 equals. Don't say the number that you get. If you're a backwards calculator person, you had to put the number first, then shift tan. So you will push 0.75, shift tan. And you will not have to hit equals. Now that everybody has done it, because those are the only two ways you could do it, what is the value of this angle? What does your calculator show you? No. It shows you 36.68, blah, 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 yes? It doesn't matter, it doesn't matter. Angles, we round to the nearest degree. Because angles are actually measured like time. There are 60 minutes in 1 degree, and there are 60 seconds in 1 minute of degrees. So the decimals, which are based on 100, don't really work. So we round to the nearest degree. Everyone cool? So this is 37, yes? Which means how big was our angle in the very first one that we were working with? 37, because it was 3/4, right? Everybody cool? Okay, now, you guys shouldn't have the negative there. What would this really be as a fraction? It's tricky. You wouldn't round up. What would it be if it was 0.23? Jacqueline? It would be 23 over 100, yes? How many hundreds are there in 1? 100. So this would be 123 over 100. Everybody agree? So 123 over 100. What would the triangle look like? There's my angle B. What would it look like? How far would I go this way? 100. How far would I go up? 123. And there's that triangle. Everybody understand? Now, Tell me what angle B will be. It's exactly like what you did here, but you used 3 and 4 or 0.75. So what are we going to use here? We're going to use, that negative shouldn't be there. We did shift tan of 0.75. So what are we doing here? Math's always the same, ladies and gentlemen. If I went shift tan and the decimal here, what do I do here? Shift tan and the decimal. And what do I get? B equals 89.5. Yeah? Everybody cool? Is it 89.5? I don't have my calculator. Yeah? Okay. What then will this one look like? What is that as a fraction? Jacqueline? 25 over 10. So what will the triangle look like? There's angle C. How far do I go this way? How far do I go up? Could I go this way 100? Then how far would I go up? 250. What if I went this way 15? How far would I go up? 37.5, because I went out 1.5, so I would go up 1.5. Is everybody cool? What is angle C's value now? What? That doesn't seem right to me. Somebody's wrong somewhere. One of those two is wrong. I will have to check it. Even though all of you have the same calculator I have and you had to push the same buttons. For which? See, that sounds better. 68. And this is 51. Okay. Yeah, which rounds up to 51. Addison.
What'd you press in your calculator to get that? Because I got some of the answers right, doing the same thing, but then I did the same thing on other questions, and I got different answers.
Do you have a forward calculator or a backwards calculator?
I'm not sure.
Does your calculator write the word tan on
Yeah.
it? I just did that for like 10 minutes.
Okay.
Okay, so you need to follow the blue. Second, tan, then the decimal, then equals. So you will push second, tan, 1.23 equals, and you will get 51. Anybody who said 89 there, make sure you're doing this right. I would have checked, but I had to give my calculator away. Are you good now, Addison?
I think so.
Do you get 51?
Yes. Yes, I get it.
Did you get 68 when you did shift tan 2.5?
Yes.
Excellent. Okay. So now we got to be smart about this. We know it compares the legs, right? Right? We've already talked about that. But specifically, it compares them in a specific order, doesn't it? If this is my angle, A, B, or C, what went in the numerator spot? The vertical one or the horizontal one? The vertical one, yes? And the horizontal one always went in the denominator, right? Everyone agrees? Okay, so what if I take this triangle right here and I rotate it. Well, now this is the vertical one. So can we say vertical and horizontal? No, because the triangle can turn around, can't we? But we can say something else. If I start here and I go across the shape, what does across mean in trig? Opposite. So the opposite one goes on top. And then this one that's right beside is called the adjacent. Now, what's the side that we never use when we're doing tangent? Hypotenuse. So, is this line in any of them ever going to be allowed to be opposite or adjacent? No, because it's already got a name. What's its name? Hypotenuse. Or, if you're in my grade 7 class, hippopotamus. Everybody good? All right, now let's apply this knowledge. Here is angle A. Everyone agree? Well, the tangent of angle A, we know, is opposite over adjacent, yes? So if we're working from angle A, what is opposite to A? What does opposite mean in trig? Across. So here is A. What is across the shape from A? 12. What is adjacent to A, but isn't the hypotenuse? 5. Everybody cool? Everybody understand? All right. Now, here am I. Right now, I'm your math teacher. There's my eyes. Wait, I have brown eyes. My wife says they're hazel, but that's just what people with brown eyes say, so they don't have to say I've got brown eyes. And, of course, because I didn't start getting ready for school today because I looked at the internet and it said school was closed, I didn't shave, so I have lots of gray stubble today. And I'm wearing sweats and a long-sleeve t-shirt. I am up there at A right now for this question, yes? What has happened over here? Where am I now? I'm at angle B, so I am going to slide down the triangle to here. What is the tan of B? Well, tan is always opposite over adjacent, so what is opposite to B? 5. And what is adjacent, but not the hypotenuse? 12. Does everybody see? Opposite and adjacent changes depending on where you are in the triangle. Is everybody cool? What line never changes? Hypotenuse is always the hypotenuse. Everybody good? Okay. So now we have two ratios, don't we? How will we find the value of these two angles when we have the ratios? Will we use tan or shift tan? Shift tan. Now, in the previous examples, I gave you shift tan as a decimal, didn't I? Or I gave you tan as a decimal, didn't I? Is that the same here? Is this a decimal? No. What makes this a decimal? What do I do with those two numbers? I do division, don't I? So, if I had the decimal, I could just do shift tan, can't I? But I don't have the decimal, I got to do division, right? So what will I do with my calculator? I'm going to hit shift, I'm going to hit tan, and then it's going to want some numbers. What do I type in to get my calculator to do this work for me? Jacqueline. You will have to push 12 divided by 5. Do that and see what happens. Don't say out an answer, just do it. Don't write it down unless you're 100% sure you know what you're doing. It does. You've given me away, Jacqueline. If you do tan 12 divided by 5, it's going to give you a little tiny decimal and divide that by 5. You must use brackets. 12 divided by 5, close brackets, equals. What if you have a forward calculator? What do you think you're going to do? Or a backwards calculator, like the 5 of you that have backwards ones. You do bracket 12 divided by 5, bracket shift tan. And you will not have to hit equals. And what do you get for angle A? How big is it? 67.3, so 67. Right? Now we know that if this is 67 and this is 90, this has to be 23, right? Because it's got to add up to 180. But let's check it anyway. What do you punch in to get angle B? Same thing. Either shift, tan, bracket, 12 divided by 5, close brackets, equals, or, 5 divided by 12, 5 divided by 12, 5 divided by 12, 5 divided by 12, or 5 divided by 12, close bracket, that's supposed to be red. 5 divided by 12, close brackets, shift, tan, and no equals. What do you get there? 22.6, which rounds up to 23 degrees.
So earlier you said that we don't round up, so when do we round up and not round up? Because earlier when you were explaining how to do it over here, to the using a calculator for trigonometry and tan.
Okay. The decimal, when you're using tan, not when you're finding the angle, you don't round that. You only round angles. Everybody cool? Now look here. What you typed to do these, I want you to write it right here. Actually write the buttons that you pushed. So I don't have to answer the question 75,000 times. How did you get that? Okay? Write what you had to push. I will wait a moment for you to do so. On my calculator, my button doesn't say shift. My button says second. Then I push tan. My calculator gives me the first bracket, so I only need to push 1, 2, divided by 5, second bracket equals. That's what I push. You will have something different. So you write down what you push. Is everybody good? Yeah? Okay. Now, before we go on and actually use this, I have to give you one new piece of knowledge. In trigonometry, because the way we do trigonometry is based on the way the Greeks did trigonometry. Every other culture did trigonometry too, but we have stolen our trigonometry that we do in Canada from the Greeks. So we use Greek letters in it sometimes. Everybody draw a circle with a line through it in the middle. Just make an O, and when you get around to the middle again, make a line. That is the Greek letter theta. It makes the sound f. Just for fun, if you were to write my name would be that, a, that, I can't remember what the O is. I think it's O-S. That is Matthew in Greek. But that's not important. Anyways, theta is the letter that we use for the angle we care about. Now, there's 3 angles in every triangle, right? Theta is the one that we are going to be working with. Is everybody cool with that? Every triangle, there will always be an angle that you are going to work at. That is theta. Everyone cool? Okay. So let's look in this very first triangle. Is there an angle in that triangle that we have to deal with? I want to find the missing length or angle. Is it marked? Sure it is. I want to find that angle right there, right? So this is how you do every single trig question for the rest of this year and almost all of next year. You do this. Theta equals, what is my theta here? Do I know? Do I know what that value is? So we write an x. Once I've established that this is the angle I care about, where should I go in that triangle? Should I go there, there, or there? I should be at the angle I care about, shouldn't I? Once I am there, that means, what is that? Opposite, adjacent, or hypotenuse? How do you know it is opposite? Because it is across from me. What is that? Adjacent. How do you know? Because it's beside me, but it's not the hypotenuse. So now I come to here and I write opposite equals, oh, hey, it's 23. Adjacent equals, oh, hey, it's 15. And then I know that the tan of theta, any angle, is always opposite over adjacent, isn't it? So, tan of theta must equal, what is opposite? I've already written it down. I don't even have to think about it. What goes here? 23. What goes here? 15. Now, if I have both of these, I'm looking for an angle. Is that tan or shift tan? Shift tan. So I'm going to do exactly what I just did here. Do this with the right numbers. What are the numbers? Right there. And tell me, what does theta equal? 57 degrees. I would like for somebody else to say what it equals as well, so we don't have the 89 fiasco that we had 3 questions ago. Is it 57? Excellent. Now let's look at the next question. Is it a triangle? Yes. Does it have 90-degree angle? Yes. So does that mean we can do the exact same stuff with it? Yes. Do I have a theta that I care about in this triangle? What is it? Pardon me? Angle can't be adjacent. Angles are inside. What is the angle that I care about in here? What? Well, that's the side, because it's on the outside. Okay. Do I have an angle that I care about? Because remember, theta is an angle. Do I have an angle in this triangle that I should deal with? 15, because I know what it is, 15 degrees. So theta equals 15. Once I decide on theta, where should I go? Up to theta. So there I am. Which makes this what? Opposite, and makes this what? Adjacent. So theta is 15. Opposite equals what? X. And adjacent equals what? 37. And what do we know about every single time we see a theta, an O, and an A? The tan of theta is what? O over A. The tan of, do we know what theta is? We've got it written right here. Do we know what theta is? 15. Do we know what opposite is? What's opposite? Do we know what adjacent is? 37. How do we solve that? What's our job whenever we see an x? Isolate it. How do you get rid of this divided by 37? He waited patiently. Multiply that side by 37. What happens? It's gone. So I'm going to go ahead and erase them. What do I have to do over here? Multiply by 37. So what math do I punch into my calculator there to find x? What do you think I punch in? Remember, some of your calculators you do tan 15. Some of your calculators you do 15 tan. What is your answer? What is it? Well, it's 9.91, right? We only round angles to the nearest number. So 9.9. Is everybody cool? Your calculator is backwards. So you must go 15 tan times 37. Uh-huh. Okay. Everybody good? All right. You should all now be able to do the last one. Is there a theta? Is there an angle that we can care about? What is it? 70. Once I make that theta, where do I go in the triangle? Ah, splat. What does that make that? Y. It's a cross. Opposite equals 14. What does that make that? Adjacent equals x. What do I know whenever I see theta, O, and A? The tan of theta is O over A. Now put in your numbers. Tan of what? 70 equals what? 14 over x. Now we're going to stop for a minute because you guys screw this up all the time. Don't write this down. We want x by itself, yes? Do we want x by itself in a denominator? No, we don't, do we? So x can't be down there. So how would I get rid of this x? What do you do in algebra to get rid of something you don't like? Two x plus 7 equals 14. How do you get rid of the 7 that you don't like? Okay, what if it was 2x minus 7? How do you get rid of the 7 that you don't like? Add 7. What if it was 2x equals 14? How do you get rid of the times 2 that you don't like? Divide. Okay, so this is divide by x. How do I get rid of it? I divide to get rid of multiply. How do I get rid of divide? Multiply. If I multiply this side by x, what's going to happen here? They're gone. What do I have to do over here? If I multiplied this side by x, what do I have to do here? No. I have to multiply that side by x. Now I have x times tan 70 equals 14. Right? Just like up here, yes? How do I get rid of this 2? Grade 10. You need to be able to solve a one-step equation. How do I get rid of this 2? I divide by 2. So how do I get rid of this tan 70? Thank you. So what do I have to do over here? Divide by tan 70. Everybody cool? What's going to happen to these two tan 70s? Cancel out. And now, x equals 14 divided by tan 70. Everybody cool? Now look back over here. If that's what it ends up looking like, can't we just skip all that algebra? What am I going to write here? 14 divided by tan 70 equals x. Do that on your calculator and tell me how big x is. What is it? What is it? Got to push 5, 6 buttons, people. What is it? 5.1. Can everybody do this? Prove it. Something's weird in number 5. What's weird? There's 2 unknowns. Which one can we work with now? X or Y? Why is X the right answer? Y is the hypotenuse. And we can't do hypotenuse stuff until we know both legs, right? So we got to find X first. Is this a trig question? It's a right angle triangle. Is it a trig question? Yes. So can we apply all the knowledge that we just worked with? What did we just do 3 times in a row? The first thing we wrote was theta. Can we do that here? What is it? Theta is always an angle. I know a bunch of people are doing the work right now, but I would very much like it if somebody could tell me what I need to write here. 30, which means there I am. What does that make that? O equals X, and once I have that written, I know that tan theta equals O over A. Now put in your numbers. Tan of what? 30 equals what? X over 24. What do I do when the denominator is a number? How do I get rid of divide by 24? Multiply by 24. 24 tan 30 equals X. Now we can get a value with our calculator. What is it? $15.5. Do other people agree? 13.5. Is it 13.5? 13.85. So is it 13.85? Excellent. Is everybody cool? Now, is it actually 13.85 or is the whole screen full? Whole screen's full, right? We've rounded this off. In the 10th grade, it is perfectly acceptable for you to take this number here and write it right there. That's okay. And then, how would we find the hypotenuse? We would do Pythagoras, yes? We would say y squared equaled 13.85 squared plus 24 squared. And then we would square root the whole thing to get y, right? Everybody do that, please. What does y equal? You've just done 2 pages of Pythagoras practice. You should be able to do that, especially because you learned Pythagoras in grade 6 or 7. What do we get here? $27.7. Is everybody cool? Everybody good? Now, listen to me. You don't have to do this year, but I want you to be aware of it. This isn't really the answer, is it? This is actually 24 tan 30, isn't it? Everybody understands that? So this should really be 24 tan 30 squared plus 24 squared. And then you would square root that answer. Now you'll get something very, very close, right? Very close. And in grade 10 it doesn't matter. But as you go further and further and you're being more and more precise with what you are doing in math, you're going to want to not round that off until the end. Is everybody okay with that? This is perfectly fine in grade 10. But the more you practice, the more often you're going to see this. Kind of like how we did pi, right? How we were leaving the answers as 64 pi instead of 186.137947, right? It's just like that. But you don't have to do it. Is everybody cool? Okay. Let's see if you can set these up. No calculators. I don't want the answer. Just set up these 3. After you've set them up and you've seen that they're right, you can go to your calculators. Okay? I don't know why Groupon thinks I need a new mattress so badly. But it does. I'm going to write all the setups up here, and then I'm going to turn it on in a second and check your work. Does everybody have all their stuff written? To the best of their ability. Because I said no calculator, so that middle one causes you a bit of trouble, right? To set it up without using your calculator, yeah? You have to do what I just showed you. Is everybody good? If you left out trying to find y on the middle one, that's okay. Everybody thinks they're good? Do you have shift tan 35 divided by 50 to get an answer? Okay, now go ahead and tell me what that answer is. Do shift tan 35 divided by 50, and what do you get? Some of you have already done it, even though I said to wait, but go ahead. What do you have? It's 3 buttons, people. What is the answer? 88? I don't think so. 35 divided by 50 is what? Shift tan. 35 divided by 50 equals. What is it? 0.61 is the decimal, but I need the angle, Rylan. So you got to shift tan that decimal. 34.99. So what do we round that to? 35 degrees, because that's what was missing. It was a degrees. Now, what is x? You had to do 7 times tan 60. What is x? All you have to do is push 7 times tan 60, or 60 tan times 7. Anyways, your homework is number 10 and just try to do number 10, because we didn't get as far as I wanted to. See you tomorrow.